to our educational channel. In this video, we present grade 11 chemistry multiple choice questions with deep and detailed explanations for each answer. These questions are carefully designed to help somebody enhance their understanding of core chemistry concepts and prepare for exams effectively. Whether you're studying for school tests or national exams, this video will boost your confidence and knowledge. Don't forget to subscribe to our channel for more videos on chemistry, physics, biology, woodwork technology, English, mathematics, and other subjects. Stay tuned for more content to support your academic journey. Let's dive into the question now. 1. Which of the following scientists is not associated with the initial development of atomic theory? A. Democritus. B. John Dalton. C. James Clerk Maxwell. D. J.J. Thomson. Answer: C. James Clerk Maxwell. A. Democritus. He was an ancient Greek philosopher, circa 460 to 370 BC, who proposed the concept of atoms as indivisible, fundamental particles of matter, though he did so without experimental backing. B. John Dalton. He formulated the first modern atomic theory in the early 19th century, proposing that all matter is composed of atoms, all atoms of a given element are identical, and compounds are formed by the combination of atoms in whole number ratios. He discovered the electron, a subatomic particle, in 1897 using cathode ray tubes, showing that atoms were not indivisible and had internal structure. James Clerk Maxwell, while a brilliant scientist, he focused on electromagnetism, formulated laws of electrodynamics, proposed electromagnetic nature of light, not directly the structure of the atom, making him the outlier here. 2. What key experimental observation led to the understanding that cathode rays are comprised of negatively charged particles? A. Their ability to induce fluorescence. B. Their ability to penetrate thin foil. C. Their deflection by electric and magnetic fields. D. Their emission from a hot cathode. Answer: C. Their deflection by electric and magnetic fields. A. Their ability to induce fluorescence. While cathode rays do induce fluorescence, this is merely an observation of a physical property rather than an indicator of their negative charge. B. Their ability to penetrate thin foil. Cathode rays could penetrate thin foil, but this does not prove their charge. C. Their deflection by electric and magnetic fields. This is the key observation that revealed the negative charge. Because magnetic and electric fields interact only with charged particles, the bending of the cathode ray beam in the presence of such fields indicates that the particles within the beam possessed an electric charge, and the direction of deflection indicated a negative charge. D. Their emission from a hot cathode. The emission of cathode rays from heated metals is important for generating the rays, but it doesn't describe their composition. 3. Rutherford's gold foil experiment primarily revealed: A. The existence of electrons. B. The existence of a dense, positively charged nucleus. C. The existence of neutrons. D. The plum pudding model of the atom. Answer: B. The existence of a dense, positively charged nucleus. A. The existence of electrons. J.J. Thomson discovered electrons, not Rutherford. Rutherford's key observation was that while most alpha particles pass straight through the gold foil, a small fraction were deflected at large angles, even backwards, which indicated the existence of a very small, very dense region with positive charge, the nucleus. C. The existence of neutrons. Neutrons were discovered later by James Chadwick. D. The plum pudding model of the atom. Rutherford's results disproved Thomson's plum pudding model of atom, where negatively charged electrons were embedded in a positively charged sphere of atom. 4. An atom has a mass number of 35 and an atomic number of 17. Which of the following is true? A. It has 35 electrons and 17 neutrons. B. It has 17 electrons and 18 neutrons. C. It has 35 protons and 17 electrons. D. It has 17 protons and 35 neutrons. Answer: B. It has 17 electrons and 18 neutrons. A. It has 35 electrons and 17 neutrons. The number of electrons is the same as the atomic number in a neutral atom. B. It has 17 electrons and 18 neutrons. The atomic number defines the number of protons and equals the number of electrons in a neutral atom, so 17 electrons. The mass number is the total number of protons and neutrons, thus it has 35 minus 17 is equal to 18 neutrons. C. It has 35 protons and 17 electrons. The atomic number defines the number of protons and does not equate to the number of electrons. D. It has 17 protons and 35 neutrons. The mass number does not define the number of neutrons. 5. Isotopes of an element have the same number of blank space, but different numbers of blank space. A. Neutrons, protons. B. Electrons, neutrons. C. Protons, neutrons. D. Protons, electrons. Answer: C. Protons, neutrons. A. Neutrons, protons. Isotopes of an element do not have same number of neutrons. They also have the same number of protons. B. Electrons, neutrons. Isotopes of an element have same number of electrons, but different number of neutrons. C. Protons, neutrons. Isotopes are atoms of the same element, therefore, must have same number of protons, which equals to its atomic number. They vary from each other due to the different number of neutrons in their nuclei. D. Protons, electrons. Isotopes of an element must have same number of protons and same number of electrons in a neutral atom. 6. Which of the following is not a characteristic of electromagnetic radiation, EMR? A. Wavelength. B. Frequency. C. Speed. D. Mass. Answer: D. Mass. A. Wavelength. The length between successive crests/troughs of a wave, measured in meters, m. B. Frequency. The number of oscillations or cycles per second, measured in Hertz Hc. C. Speed. The speed of light, c equals 3 times 10 to the power of 8 m/s in a vacuum. All electromagnetic waves travel at this speed. D. Mass. Electromagnetic radiation does not have a rest mass according to classical physics, although it has energy which can be related to its mass by E equals mc squared. 7. Which type of electromagnetic radiation has the highest energy per photon? A. Radio waves. B. Microwaves. C. Infrared radiation. D. X-rays. Answer: D. X-rays. A. Radio waves. These have the lowest frequencies and lowest energy. B. Microwaves. These have higher frequencies than radio waves, but lower than visible light. C. Infrared radiation. This falls between microwave and visible light in terms of frequency and energy. D. X-rays. These have high frequencies and high energy, making them the highest energy option of the four. 8. According to the quantum theory of light, energy is A. Continuous, B. Quantized, C. A wave, D. A particle. Answer: B. Quantized. A. Continuous. Classical physics suggests that energy is emitted and absorbed continuously. B. Quantized. This is correct. Planck proposed energy is emitted or absorbed in discrete packets called quanta. C. A wave. While light behaves like a wave, the quantum theory speaks about the packets of energy. D. A particle. While light behaves like a particle, that doesn't explain the concept of it not being continuous. 9. In the photoelectric effect, electrons are ejected from a metal surface when light shines upon it, but only if the light has a frequency that is A. Below the threshold frequency, B. Equal to the threshold frequency, C. Above the threshold frequency, D. Any frequency regardless of its value. Answer: C. Above the threshold frequency. A. Below the threshold frequency. If the light's frequency is below the threshold, no electrons will be ejected regardless of the intensity of light. B. Equal to the threshold frequency. The light frequency at the threshold frequency, VO, will release electrons, but at no or a minimal kinetic energy. C. Above the threshold frequency, electrons are ejected from the metal surface when photons of frequency equal to or more than the threshold frequency collide with the metal. D. Any frequency, regardless of its value. The minimum energy needed for electrons to escape is a specific energy, therefore frequency. 10. Which is not a postulate of the Bohr model? A. Electrons orbit the nucleus in specific paths. B. An electron can only have certain energies corresponding to the allowed orbits. C. An electron can transition between orbits by absorbing or emitting energy. D. The electron does not emit radiation when moving around the nucleus. Answer: D. The electron does not emit radiation when moving around the nucleus. A. Electrons orbit the nucleus in specific paths. The Bohr model postulates that electrons move around the nucleus only in certain fixed orbits with specific energy levels. B. An electron can only have certain energies corresponding to the allowed orbits. Only specific energy levels or orbits are permitted, which are called quantized energy levels. C. An electron can transition between orbits by absorbing or emitting energy. When electrons jump between energy levels, they emit or absorb a specific amount of energy corresponding to the energy difference. D. The electron does not emit radiation when moving around the nucleus. This statement is false as electrons are supposed to have specific fixed orbits in the Bohr model. Thank you for watching. Remember to like, share, and subscribe for more content on chemistry. Stay focused and keep learning. Bye-bye until we meet in the next video.